question that we are going to answer in this video is as follows. So the question is, given a vector in R3, let's call it V, and an unit vector in, once again in R3, what happens if the vector V rotates around the vector N by an angle, say theta? So the question is, what will be the new position of this vector V? Let us now draw the diagram. Let this green line represent the vector N, which is of unit length or unit norm, and then let this red line represent the vector V, and this point is the origin of the coordinate system. Now what happens is as follows. This vector V rotates around the vector N in this, along this circular path or locus. So the tip of the vector V, this point, rotates along this circular line, while the other end of the vector V stays still at the origin. So the question is, if it is rotated by an angle theta, what will be its new position? To get the answer, we shall consider a plane which passes through this point, this origin, and which is perpendicular to this axis of rotation. And then we project this circle along which the vector V rotates on this plane, passing through the origin and perpendicular or orthogonal to this vector N. So after projection, this is the projected circle. That means if I project the tip of this vector V on this plane, on this horizontal plane, then that rotates along this circle. Let me call the projection of this vector V on this horizontal plane as V perpendicular, V perp to denote the fact that this component is perpendicular to the axis of rotation. And therefore I shall also denote the other component of this vector V as V parallel, which is parallel to the axis of rotation. Now after rotation, this point V comes here, say at this point, which is drawn with this blue ink. Let me call this point as, or this vector as V prime. And then once again let me project this V prime on this horizontal plane, and therefore this vector projected on the horizontal plane will be referred to as V prime perpendicular. And then this angle is the amount through which this vector v rotates. So this angle, the value of this angle is theta. So the question, let me reiterate the question that we are trying to answer in this video once again. Given v, which is the initial vector or the initial position of the vector, then n, which is an unit length vector or the axis of rotation, and theta, the amount or angle of rotation or the magnitude of rotation. Given v, n and theta, the question is what is v prime, or what is the new position or new location of this vector. Now note that v is equal to v parallel plus v perpendicular. The two components, one along or in the direction of n or the axis of rotation, another perpendicular to the axis of rotation. Similarly, v prime is also equal to v prime parallel, which is the component of v prime in the direction of n or axis of rotation, plus the component of v prime which is perpendicular to n. Now note that in this diagram, when v rotates through an angle of theta, the component of v which is along the direction of the axis of rotation does not change. Only the component which is perpendicular to this axis rotates through an angle theta. Or in other words, v prime parallel is equal to v parallel, and therefore I can write this as v parallel plus v prime perpendicular. Now this is because v prime parallel is equal to v parallel. And what is this v parallel? This can be written as the projection of v along the direction n, that is v dot product n, v dot n times the unit vector n. Therefore, to get v prime, we only need to find v prime perpendicular, because the other component is already known. So the question is, what is v prime perpendicular? To get this answer, we shall look at this diagram from the top. So let me draw this diagram by looking along the axis of rotation from the top. So this circle on before that, let this this plane of page be the plane which is perpendicular to the axis of rotation, and therefore the center point here will be the axis of rotation, or in other words, this is how the axis of rotation is. So this point is n, and therefore this circle is the locus of the point v perpendicular. So therefore I have v perpendicular here, and after rotation this point comes here, which is V prime perpendicular. Now the question that we are trying to answer is this: what is this component? To evaluate this, we shall first consider another vector which I am drawing with this black line, which is perpendicular to V perp and which is also perpendicular to N. Let me call this vector as W, and this angle, which is the angle of rotation, is theta. Therefore, I can write V prime perp as V perp cos theta plus W sin theta. This is because if I resolve V prime perp into two perpendicular components, one along V perp, another along W, then this component is proportional to cos theta and this component is proportional to sin theta. So this equation holds true. Now I need to get the value of W in terms of the known quantities like V, N, etc. For that, note that N cross V perp is equal to W. Why? Because this is how the vector N is perpendicular to the plane of pitch, and if I take the cross product between this vector and V perp using the screw rule, then this will be the result of the cross product, which is along the W. And since the magnitude of N is equal to 1, therefore the magnitude of the cross product will be equal to the magnitude of V perp, which will be equal to W, because both W and V perp are the radii of this circle. Therefore, this implies further that N cross V perp plus V parallel is equal to W. Why? Because when I take the cross product of N cross V parallel, they are in same direction. Therefore, the cross product of N and V parallel is 0, and this is the only component that remains. Therefore, I can write that N cross V is equal to W. Let me now put the value of W in this equation, so that I get V prime perp. So let me put this in this equation first. So V prime perp is equal to V perp cos theta plus, in place of W I put N cross V times sin theta, and then therefore V prime, so I use this equation now. So V prime is equal to V parallel, which is equal to this. So V dot N times N, so this is the parallel component plus the perpendicular component, which is equal to this, which is V perp cos theta plus N cross V sin theta. Next, let me let me use this space. So now v prime, this can be written as so I shall put the value of v perp in this equation. So this becomes v prime is equal to v dot n times n plus, in place of v perp I put its value, which is equal to v minus v dot n times n. So v minus the parallel component is equal to the perpendicular component. So this times cos theta plus n cross v sin theta plus n cross v sin theta. And so now we have got the value of the new vector or the rotated vector in terms of v, n and theta. That means in terms of initial position, the axis of rotation and the amount of rotation. And this formula is known as Rodrigues formula.